All right, so as we go to negative infinity, the graph is going down, so negative infinity. It's just your end behavior. How about positive infinity? Where is this leveling off? 0. All right, cool so far. Here is -1 from the left. So here's -1, but watch me point to it. We only want to go from the left side. So what number is getting approached from the left? 3. I think I made the next one. From the right, I know it's a hole there, but again, it's just behavior. What number is getting approached? It's 1. Good. So what would -1 overall be? If the two sides don't come together, if one's up here and one's down here, good, does not exist. Perfect. All right, how about 4? Do both sides come to the same place at 4? Yes, it doesn't matter that there's a hole. Both sides are headed towards 1. So that is our answer. We have 3 from the left. So you can get an answer because it's sided. 3 from the left would be negative infinity. 3 from the right would be positive infinity, but I think this one is 3 overall. What would I have to put for that? It does not exist. Even if these were both going the same way, like even if they were both going up, it would still be does not exist because they're never going to touch across the asymptote. How did that little section go? Just looking at the picture. All right, now these are not limits. They're just actual values. So f of 4, where is the actual point at 4? -2. F of -1, the actual filled in point for -1 is 3. And then at 3, we have an asymptote, so does not exist. All right, for this one, continuous or discontinuous, we're going to say yes or no. And if it's a no, we'll explain why. So at 0, what do you think? Yes or no? Yeah, at 0, you can trace through there without lifting your pencil. So that's yes. And so that's great. You don't have to say anything else because it's just yes. All right, how about 3? Yes or no? No, there's an asymptote there. So we would say f of 3 does not exist. It's the notation that gets everybody. The yes or no goes fine. I mean, that's common sense, but you would say there's not a point there. F of 3 does not exist. All right, how about at 4? Yes or no? No. That is also a no. Again, you're going to get that part. That part's fine. There is a point. There is a limit, but they don't equal each other. Do you see how the limit is up here, but the point is down here? So the way we write that is f of 4, do you remember what we put after that? Is not equal to limit as x approaches 4 of the function. Have you ever used a test to help you take a test? I know this is only going to be a quiz, but have you ever used the test to help you take the test? I would do that in history all the time because it was my worst subject. And I would try to find the answer to this question in one of the other questions. Do you understand what I'm saying? If you're not sure how to write this part of it, look up here. Do you see how I basically just recopied that? Like use what's written on the paper and just copy it, okay? I'm going to not do this one because there's not one like that on the quiz. I threw that on there to practice our notations some more, but I know that we're all tired and there's not one like that on the quiz. So I'm going to just let that go, okay? Unless anyone has a burning desire to practice the limit notation where I figured not. So we're getting down to the end of May here. All right, so consider this function. We want to be continuous at -3. It's not, but we want it to be. What would that value need to be? Even if nothing I just said made any sense to you, you want to let your instincts kick in. What does it kind of feel like you need to do with the x squared minus 9? Yeah, you're going to factor it. You want to let your instincts kick in, especially with calculus. If you're going on to AP calculus next year, they are going to word the instructions in the most confusing way possible. You almost need to ignore that and just go, what does it feel like I should do? All right, so what's that going to split into? Yep. Good, perfect. X plus 3, x minus 3. And then what happens? Those cancel. That means there was a hole. That's why it wasn't continuous, is because there was a hole. And then what are you going to plug into what's left, do you think? -3 is the value that we want to plug in. So if you plug in -3 there, -3 minus 3 is -6. And that's the answer. That's what you're doing there. You're finding what the y value of the hole was, is what's going on there. Same thing with this one. This all looks, you know, super confusing, so forget it. What did I tell you to multiply by when there's a root? Begins with a C, it's a conjugate, because that's what's going to make things cancel out. So you're going to multiply by square root of x plus 7 plus 3. And yeah, you have to write that twice, but in the next step, everything's going to cancel out. So just, you know, trust the process. So if we multiply all of that together, square root of x plus 7 times square root of x plus 7 would just be x plus 7, and that's kind of the whole point, all right? And then negative 3 times positive 3 is negative 9. If you're like, hey, what happened to the outsides and the insides? Well, what did happen to those? They cancel as well. That's why that's why we did that. One's plus, one's minus. All right, in the denominator, you're gonna just recopy this. Don't do anything to it, just rewrite it. It's a little bit of rewriting, but you don't have to like do anything. So that's my pep talk on that. Just anybody can recopy it. That looks like a mess. However, stop, take a step back, look at what you've got. What is gonna happen now? Yeah, it will cancel. Do you see how x plus 7 minus 9 is x minus 2? So those cancel. Your numerator is now just 1. And what number are we going to plug in for x? Read back through the problem. You're going to plug in 2. Okay, so here we go. 2 plus 7, 9. Square root of 9 is 3. Plus 3 is 6. So again, you want to let your instincts kick in. The directions are going to be confusing, so just don't read them. All right, number 7. This is our function. And we are told f of negative 4 equals 1. Don't forget that. That's what I'm about to say. Is the function defined at negative 4? Yes, it equals 1. It's almost like a trick question. Yes, it's 1. You got told that. It is a trick question, though. Does the limit exist? All right, now that is going to involve factoring. Draw your 2 sets of parentheses. It's going to split x and x. And then how would the 4 split up? Yep, 4 and 1. And then we would need to get 3 in the middle. Plus 4 minus 1. Oh my gosh, something cancels. Isn't that crazy? And then what are you going to plug in to what's left? Negative 4. So if you plug in negative 4, you get negative 5. So is there a limit? Yes. We didn't get D and E. We got an answer. So yes. So before I read part C, there's a point at 1, but the limit is at negative 5. So is the function continuous? No. It would be a situation like this, where there is a point and there is a limit, but it's like, haha, I tricked you. I stole the point. It's over here now. That's what it would look like. You guys are quiet, but this feels like this is going well. So good. All right. Suppose this is your function. Looks super fun, right? At what x values is the function discontinuous? Negative 1 is a trick question, so I'm actually going to change this. Do you see how there's not an equal to on either of them? So could the function be continuous there? No, but I want it to be more like what your quiz is like. All right, so can you just put an equal to on that one? We'll pretend there's an equal to there. So what you want to do is plug negative 1 into the first part and plug negative 1 into the second part and see if they equal each other. That's all we're going to do. So here we go. Negative 1 squared. 1 plus 7, 8. Good. And then negative 1 plus 9 is 8. So at negative 1, we're good. Now we're going to do 3. So we're going to plug 3 into this part, 3 into this part. 3 plus 9, 12. 2 times 3 is 6, plus 6, 12. Great. So 3, we're good. Now we're going to do 5. If you plug 5 into this piece of the function, what are you going to get? 16. And if you plug 5 in here, or any number really, you're going to get negative 4. So those don't equal each other. So we are discontinuous at 5. And then this one kind of doesn't make sense anymore because I told us to put the equal to there, but it's what would f of 1 need to be continuous? Well, what did we get when we plugged in -1 to both of those? When we plugged in -1 here and plugged in -1 here, what did we get? 8. So that would have been the answer to that, but I wanted us to put the little equal to on it. All right, we'll do one more and then we'll do like our halfway break. So say this is your function. We want the function to be continuous. That means you need to set the two parts equal, all right? So we're gonna have x squared plus 10x over x equals x plus 2k. So you just set them equal. On the quiz, it's a point for doing that. You just set them equal. You are going to need to factor here. Let your instincts kick in. If you see a squared, you're probably gonna have to factor. We're gonna take out a greatest common factor, which would just be x. There were a bunch like this on the delta math. And then what would be left? X plus 10. And the whole point of doing that is what cancels. Yeah, the x's cancel. And then what are we going to plug in for x? Do you think? Use your instincts. It is on the paper. What do we plug in for x? 0. Good. So this would be 0 plus 10 equals 0 plus 2k. I wrote it because on the quiz, I think it's not 0. It would just be a different number. But anyway, you just plug in that number. But this is 10 equals 2k. So what's k? That's good. So if it says continuous, you set them equal and then plug in whatever number for x. So I'm going to do these ones first, so it'll be more like in the order that I taught it. So for this one, we're looking at a piecewise function broken at 2. So when it says 2 from the left, and believe it or not, this is one of the more commonly missed problems, and it's really not that hard. So like, please listen to me. I want everyone to get this right. 2 from the left just means you're going to plug 2 into the first one. That's all that means, from the left. So smaller than 2. So if you plug 2 into that, what do you get? 0. Perfect. That's it. Don't overthink that. People plug in a number that's not 2. Like plug in the number, right? 2 from the right means you're going to use this piece of the function. So if you plug 2 into that, 2 times the 4, 2/4 be a half minus 3 would be -2.5. So from the left, it's 0. From the right, it's -2.5. So even without looking at any of this, what's the overall answer? Does not exist. And what would that look like? Can you visualize it? If one side goes to 0 and the other goes to -2.5, a jump. Good, it would be a jump. All right, these are all the ones to infinity. That's who's in charge here. So let's see, for this one, it is the 3x squared. And on the denominator, the -1x squared. So when it's the same, what's our method? All right, coefficients. So 3 over -1, -3. All right, for this one, you've got -x and 2x squared. So the numerator is smaller than the denominator, 0. It's automatically 0. All right, here, these are quick because they're like no work. All right, we've got square root of x and we've got -8 square root of x. So again, that's a tie. So your coefficients will give you what? -1/8. All right, here we've got 4x to the 5th and -10x to the 3rd. So if the numerator is bigger than the denominator, it either goes up or down. It's a slant asymptote. So it either goes up or down. You're just testing if it's positive or negative. So if you plug in a really big positive number to these, it's going to end up being negative. So -infinity. At that point, you have a 50-50 shot. All right, here we've got -3. It's really -3x to the nothing, if you want to put x to the 0 on there, if that helps you. And then on the bottom, -2x cubed. So what situation is that? Yep, 0, numerator smaller. And then these two are the same kind of problem. The only difference is I threw a negative in this one. So if you were to plug in a really gigantic number, you make it negative, it reciprocates that. And this part becomes very, very unimportant. So you end up with 1/2 is what happens there when it's negative. If there's not a negative, if you plug in a really, 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 really huge number, this is the most important part of the whole thing. The denominator is astronomically large. So what's it gonna go to? The denominator is just huge. 0, because you end up, if you go out to infinity, you end up with a situation like 1 gazillionth. Do you know what I'm saying? Like the denominator is super huge. You have like 1 trillionth of something, which is super tiny. It's gonna go to 0. Those are hard though. I don't think the rest of them were too bad. All right, so let's go back and get these. These were the kinds of things we did last time that involve some work. So I saved the hardest page for last. This is supposed to be bolded here. We did one of these last time where we drew it. Do you remember what this graph looks like? Good. And I didn't move it around at all. So it's just centered at 0. So that's where your first step is going to be, starting at 0, and just draw in a few because we want to approach 3. So like go far enough that you get to 3. Or if you're capable of visualizing it, you actually don't have to draw a graph. I don't need a graph. That's not part of the work. If you're able to like hold it in your mind, then you can do that. I cannot. So I have to draw it. All right, it's 3 from which side? The left, the little negative there. So watch me point to it. 3 from the left. I know there's a hole there, but it doesn't matter. What value are you on? 2. So 2 is your answer. Follow-up question. Let's say it was from the right. Then what would your answer be? 3, because you'd be up to the next step. Cool. This one's going to involve a little bit of work. All right. Here's what I would do. I would put the 2 over 1. And there's always multiple ways you can get through things, but this is how I'm going to explain it. This is what I would do. And then you want to get a common denominator, which will be 1x. So I'm just going to multiply that fraction by x. This is like algebra. Limit problems are just algebra with the word limit in front of them is all it is. And so we're going to put all of that together. It'll be 8 plus 2x over x. I just put all that together. Now, I don't want to now put that all over x plus 4. So instead, what I'm going to do is change it to multiplication and put the reciprocal, because I think that that looks a little bit better. That's my personal. All right, then we're going to need to factor. So what is your greatest common factor from these two? 2. So put a 2. What's left when you factor out a 2? Yeah, and it would be 4 plus x, but you can write x plus 4 as well if that like suits you better. Again, a lot of it comes down to personal preference, but the point is they're going to cancel. The point is that it's going to cancel. And then what do you plug in for x? -4 is what we're going to plug in for x. So you'd have 2 over -4, so -1/2. Let me just bring this up real quick because, wink, wink. Let's say instead it came out to this, and I'm going to just, give me some single digit numbers. I'm just going to invent something. This doesn't really matter. We'll put x minus 3. So the question we just did was adding. It doesn't matter what order you add. 4 plus x is the same as x plus 4. Do you see how these are subtraction and it's opposite though? They still cancel, but watch. You cancel them and you just put a little negative out front. That's it, because it's reversed. Cool. Heads are nodding, so I'm good with that. Let's plug in 0. What do you get if you plug in 0 to this? 7 over 0. Does anyone remember what that means is in the graph? It's an asymptote. Okay. So your next question is this sided from the left or the right? No. So it has to be DNE. You can only get an answer for an asymptote if it's from one side or the other, because the two sides are never going to touch. If you have an asymptote, it's like prison bars. It's never going to touch through that. All right, let's try and plug in -4 to this one. If you plug in -4, you're going to get -3 over 0. So same thing, but is this one sided? Yes. It's from the right. So picture a number line. What's a number to the right of -4? -3. So we're going to plug in -3 and just see if it comes out positive or negative. That's it. So if you plug in -3, you're going to get -2 over, what is that, 9 minus 16, so -7. But that result will be positive, so positive infinity. You're just checking if it comes out positive or negative is all that is. All right, here we're going to plug in 2. 2 squared is 4. Minus 2 is 2. Plus 4, 6. And then how about the denominator? Would that be 3? So 2. Always try and plug it in first. If you did a whole bunch of work trying to factor that only to find out it doesn't actually factor, you're going to be upset if you found out you could have just plugged in 2. All right. So let's try that again here. If you plug in 3, 3 minus 1, 2 squared is 4, minus 4, 0. And then the denominator will also be 0. Okay, so you are going to have to do some work for this one. X minus 1 squared means this. And if you're able to hold that in your head, you don't have to write it if you're like at the point where you can just multiply it out, but otherwise then write it. So x times x squared. Outsides give you minus 1x, insides give you minus 1x. So together, minus 2x. Now hold on, don't write this yet. Negative 1 times negative 1 is just 1 minus 4. 1 minus 4, negative 3. Cool. Now what? Factor. Good. Perfect. You guys have good instincts. So what's that gonna split into? Yeah, one of them's gonna have to be x minus 3, right? And then the other one would be x plus 1. All right, so those cancel, and then what do we plug in? 3. 3 plus 1, 4. Cool. Almost there. You guys are hanging in there. I saved the hardest page for last. All right, same thing with this one. If you plug in 0 for h, you're going to end up with 0 over 0. So we're going to have to multiply this out. So it's going to be x squared minus, and then what you want to do is write that twice. Or if you can hold it in your head, then that's fine, but I would write it twice. So x squared minus, and I'm going to keep the parenthesis there for a second. You'll see why. Let's multiply it together. X times x squared. The outsides give you minus xh. The insides give you minus xh. So together, 2 of them. And then negative h times negative h is plus h squared. And the reason I kept the parentheses there is because you have to subtract the whole thing, which means what are you going to need to do with that negative? You're going to have to distribute. I'm going to just erase it. You can rewrite the whole thing if you want to, but when you distribute a negative, everything is just going to change its sign. So it's going to look like that. And like the worst is behind us. Now stuff should start canceling. You kind of have to get through that like difficult step first, and then stuff should start going away. So what's going to go away here? All right, the x squareds are gone. And then out of what's left, what can you factor out? H. Good. So that would leave you with 2x minus h. I know you're like every letter of the alphabet is in this thing. Kind of like that. Then what happens? H's cancel, and you're going to plug in 0 for h. So if you plug in 0 for h, that's gone. What's the answer to the whole thing? It's 2x. Don't be surprised you have an x in your answer. There was an x and an h in the problem. Okay. This one, what was like the go for broke, Hail Mary, if nothing else works message? Do you remember what we did? Draw a picture. All right. So let's just go and draw a picture. Now you've encountered one like this before, but I believe in you. Where is the weirdness going to happen? What number do you think? Well, not -2, but 2. Yeah, at 2 is where, you know, we're going to run into some trouble. You actually can't plug in 2. It's not defined there. Let's try and plug in 3. Ready? I'm just going to talk you through this. 3 minus 2, 1. 3 minus 2, 1. 1 over 1 is 1. So you get 1 there. How about 4? You plug in 4. 4 minus 2, 2. 4 minus 2 is 2. 2 over 2 is 1. I could keep going, but do you understand that it's gonna be one forever and ever and ever and ever and ever? Like, no matter what happens, you're gonna end up with one. So that piece of the graph is gonna look like that. When you go the other direction, it's going to be at -1. And that is because one of the pieces gets absolute valued and the other does not, ends up being negative. So here's the takeaway. Your answer is either 1 or -1, just depends on which side you're approaching from. So which side are we approaching from? The left. So what's our answer? -1. I like those graphs though, those are cool. All right, let's plug in 1. 5 times 1, 5, minus, now it's gonna give you 7/0. This means asymptote. That first part ends up not mattering at that point. This means you're gonna have an asymptote. So is it sided from the left or the right? No. So what's your answer? Not exists. So they're not all gonna be super hard. Like some of these were a little bit more difficult, but then there's gonna be easier ones too. You have to, find the easy ones. For this one, I would draw a picture. What direction did this get shifted? Left or right? It's kind of backwards. Wait, left 7. So you're gonna go to -7, dot in the asymptote, and it's gonna look like that. Remember, E is a swoop. Ln is the inverse of that, so it's a sideways swoop. So you want to approach -7 from the right, which is good. You can't approach it from the left because there's nothing there. Where is the graph headed? Down, so -infinity. This one's going to be a little bit different. This one, I knew we were going to need a graph because it's approaching where the asymptote is. This one's not approaching 2, though. It's approaching 3. So ready? Let's just plug in 3. 3 minus 2, 1. You get ln of 1, which we did talk about last time. I want to see if anyone remembers. I know a weekend happened, but ln of 1 is 0. Good job.